You know, it's funny. Have you ever wondered why building what should be a simple app can end up feeling like this incredibly chaotic mess? Well, today we're going to explore a totally different way of thinking about building software. It's one that treats it more like a construction project, starting with a solid, reliable blueprint. Okay, let's just get right into it. Have you ever been on a project, and I mean even a seemingly simple one, that just completely spirals out of control? You know the feeling. You start with this really clear goal, but somewhere down the line, things just get messy, confusing, and honestly, pretty stressful. Yeah, this probably sounds familiar, right? These are the usual suspects. You've got scope creep, where new features just keep getting added. You've got requirements that somehow get forgotten. People start using different words for the same thing, and it all leads to that frantic last minute scramble before a deadline. But what if there's a better way? So, how do we actually escape this cycle of, just constant last minute chaos? Well, the answer is to adopt a much more structured, plan first approach. Let's call it the spec-driven blueprint. I mean, think about it for a second. You would never build a house without a super detailed architectural plan, right? You'd want to know exactly where the walls go, where the plumbing runs, how it all fits together. So why on earth should software be any different? That blueprint, that's the key to a predictable, successful project. Okay, so what is spec-driven development, really? Well, it's a method where that detailed specification, or spec, isn't just some document that you write once and then gets filed away and forgotten. No way. Instead, it becomes this active, central guide for the entire project. It's the single source of truth that informs every single decision. All right, so that's the big idea. But how does this actually work in practice? Well, it's all about a systematic process for turning these abstract ideas into concrete, actionable tasks. The whole process really revolves around three core documents. It all starts with the spec, which is all about the what and the why of a feature. From there, you get the plan, which outlines how you're going to build it technically. And finally, that gets broken down into the tasks, which is basically the step-by-step instruction manual for getting it done. And it all kicks off with something super simple, like this, a clear user story in the spec file. Now notice, this isn't technical jargon, right? It's just a plain language description of what the user needs, and crucially, why they need it. This right here is the foundation for everything that follows. So you take that simple user story, and now the plan file starts to translate the what into the how. It lays out the high-level technical approach. In this case, it's going to be a Python app with a nice, clean architecture. We're still not writing any code yet. We're just designing the blueprint. And this is where the rubber meets the road. This is the final step of refinement. That technical plan gets broken down into these tiny atomic tasks. Every single one has a unique ID, a super clear description, and it even tells you exactly which file to work on. It's like a precise paint-by-numbers checklist that guides the developer and just removes all the guesswork. But look, a beautiful blueprint is totally useless if it has a giant flaw in it, right? That's why the next stage is so critical. It's all about building quality into the process itself, not just, hoping to find bugs at the very end. This whole approach is all about being proactive. So instead of waiting for a bug report after the software is already built, this system has these quality gates that inspect the plan itself. It's like having an architect review the blueprint for any structural problems before a single brick ever gets laid. And the system has some really cool tools to make this happen. There's a command /sp.analyze that can automatically scan all your documents to find any contradictions or gaps. And even more powerful is /sp.checklist, which can generate what are essentially unit tests for your requirements. And that's a really neat concept. Okay, now this right here is the aha moment. We all know what a code unit test is, right? It just checks if a piece of code does what it's supposed to do. But a requirement unit test? That checks if a requirement is actually well-defined. So it asks questions like, is a vague term like fast loading actually defined with a measurable number, like, say, under 500 milliseconds? This makes sure your goals are crystal clear before you ever write a single line of code. So you've got this precise plan. You've done a rigorous quality check. What does the actual building part look like now? Let's see how it all comes together. When you've done all that hard work of planning and refining up front, the actual building phase becomes incredibly smooth. There's no guesswork, there are no last-minute arguments about how a feature should work. The team can just focus on what they do best, executing a clear and well-vetted plan.
So, how does this translate to real work? Well, for that Simple To Do app we've been following, the entire first phase was completed in exactly 38 distinct tasks. That's not some vague estimate. It's a tangible, measurable amount of work that came directly from the plan.
And what did those 38 tasks actually get us? 5 fully functional features that mapped directly back to the original user stories in the spec. You can see this perfect, traceable line all the way from the initial idea to the final, valuable outcome. It's so clean.
But here's where things get really interesting. This system isn't just for brand new projects. In fact, one of its most powerful features is how it can handle code that already exists.
I mean, we've all been there, right? We've all encountered that legacy codebase that, well, it works, but nobody really understands how. They're like houses that were built without any blueprints. So what if? What if you could generate the blueprint after the fact?
This idea actually has a name, and it's a pretty cool one: software archaeology. It's the process where the system can analyze an existing codebase and literally work backward to create the documents that should have existed from the start. It extracts the spec, the plan, and the tasks, basically reverse engineering the original intent from the final code. And that's the idea I really want to leave you with. Just think about what it would mean for software maintenance, for bringing new people onto a team, for modernizing old systems. What would it mean if you could generate a clear, understandable blueprint for any piece of code? It just might be the end of chaotic software development as we know it.